Hello and welcome. My name is David Miller, Vice President of Cheminformatics at Simulations Plus. Thank you for tuning in to this training video on 3D functionality within ADMET Predictor, specifically 3D conformer generation and virtual screening. Something I want to make clear at the outset is that all the 3D functionality I'll show today is free of charge for all clients with a license to any property prediction module. So if you license physical chemical properties, for instance, the pKa predictions and so on, then these 3D capabilities are already accessible without any other additional license. So this video is not a sales pitch, but rather an introduction to functionality you already have, and we hope you'll take advantage of it. I'm going to start by launching the graphical user interface for ADMET Predictor, which I'll be using today to illustrate the functionality. Be aware that the same 3D functionality is also available using the command line interface, which does run on both Windows and Linux. So I'm going to start by opening an SD file that contains 1,000 commercial drugs. Now this file contains only 2D atomic coordinates, and that is sufficient information to predict all of the ADMET properties that we offer, since the models for those properties were built using descriptors that are 2D in nature. We have, however, developed a few models that use 3D descriptors, and running these models requires a single 3D conformer for each compound. I can view the list of those 3D models by launching the model editor and looking for entries in the column labeled 3D file name. So you can see there are two shown here, one for MDCK permeability and one for aqueous solubility. I think we have about a dozen 3D models in total right now, but we do plan to develop more in the future. Okay, in order to run those 3D models, we need to have 3D atomic coordinates for the compounds in the spreadsheet. One way to obtain those is to open an SD file that already has the 3D coordinates. Another is to generate them using ADMET Predictor. So I'll need to talk briefly about our 3D methodology. And to do that, I'll launch the main settings window in ADMET Predictor and then activate the tab labeled 3D. Now first, ADMET Predictor distinguishes between generating multiple 3D conformers, which is triggered by checking this first box, and generating just a single conformer, which is the default behavior. Since our 3D ADMET models only require a single 3D conformer, I'll leave this option unchecked for now and come back to it later when we discuss 3D virtual screening. So focusing on the parameters relevant to single conformer generation, the main ones are related to distance geometry and minimization. So the underlying algorithm uses distance geometry for complex ring systems like morphine or cubane, for example. And here you can control the number of distance geometry trials. Similarly, you can control the level of energy minimization, where energies are computed based on the MMFF94S force field. And I'll just point out that further information about the underlying methodology is described in the ADMET Predictor user manual. So keeping the default settings, and again, keeping this multiple 3D conformer option turned off, you can generate 3D coordinates either by clicking this black 3D toolbar button or choosing the corresponding menu item, which is under Tools, 3D, Generate 3D Coordinates. Okay, this laptop has 16 CPU cores, so the operation is quite fast for these 1,000 compounds. When it's done, you'll notice that the 2D structures are still displayed, but the new geometry column indicates that a single 3D conformer is now stored for each of the compounds. The 3D quality column will alert you to any structure problems like close van der Waals contacts. And the energy column will show the minimized conformer energy, which again is based on the MMFF94S force field. So what can we do with the 3D conformers? If you launch the window to predict ADMET properties, you'll see that the box for using the 3D variants of our ADMET models is now enabled. It's unchecked by default, but you can now check it. With just 2D coordinates, the box is unchecked and disabled. I won't run that now. If you export structures to an SD file, you'll have the option to export either the 2D or the 3D coordinates. If you save the entire spreadsheet in the native ADMET Predictor format, the so-called XTK format, both the 2D and 3D coordinates are saved so that when you open that file again, the user interface will look just as it does right now. Now, ADMET Predictor does not have its own 3D visualization capability. So in order to view a 3D conformer, you'll need to link ADMET Predictor to an external tool. In that same 3D settings window that we saw before, I've entered the path to an open source program called Avogadro. Many other free and commercial tools are also supported here. They just need to be able to open an SD file. So with this setting, I can click on a single structure and then click a different toolbar button. It's the white button that has the 3D label, and that will launch the external tool, which allows you to visualize the 3D conformer. So that's single 3D conformer generation.